Welcome to Algebra 2. This is our third unit of the year and we will be discussing quadratic functions. For today we will be talking about just the first section, which is graphing quadratic functions. You may remember some of this from Algebra 1, in which case wonderful. If you haven't, don't worry, I will go through this whole thing again with you. So first off, a quadratic function, what is it? The greatest exponent is 2. This is also known as a parabola. They look something like this. Okay, you could be facing up or you could be facing down. We know it's a quadratic function if it can be written in the form f of x is equal to ax squared plus bx plus c. Remember, f of x is just our function notation. So we're going to start off by graphing the following function. F of x is equal to 3x squared minus 12x plus 6. Well, how can we possibly graph this? All right, so anytime you don't know how to graph something, you can just make an xy chart. You just pick points for x, plug them in, and solve for y. Typically, you can start from finding values from -2 to +2. So here, if we plug -2 in for x, we'd have 3 times -2 squared minus 12 times -2 plus 6. That's 4 times 3 is 12, plus 24 plus 6. Well, this ends up giving us, what's that, 42? Well, that's just way off the graph. So we can skip a few numbers. So let's skip to 0 because we want to find points that are close to our graph. If we plug 0 in here, we'd have 3 times 0 squared minus 12 times 0 plus 6. So 0, 0, and then just plus 6. So we get 0, 6. So that's better. So let's move on to 1. So 3 times 1 squared minus 12 times 1 plus 6. So this would be 3 minus 12 is -9, plus 6 is a -3. If we plug in 2, 3 times 2 squared minus 12 times 2 plus 6. 2 squared is 4, so this is 12 minus 24 plus 6. So that should be -6. If we plug in 3, we have 3 times 3 squared minus 12 times 3 plus 6. So 3 squared is 9 times 3 is 27. Minus 36 plus 6, so that would be a -3. And then we have 4, 3 times 4 squared minus 12 times 3 plus 6. 4 squared is 16 times 3 would be 48. I'm sorry, 12 times 4. Minus 12 times 4 is 48 plus 6, so that gives us 6. Notice last time when we had 6 over here, we went really far off the graph, so we'll just stop there and we'll plot those points. So we have the point 0, 6, and the point 1, -3, the point 2, -6, the point 3, -3, and the point 4, 6. So it does look like this parabola right here that's facing opening up, so we'll go through and we will graph that parabola. So there we graphed it. Now, if we take a look at this graph, there are a few things I want you to take note of. The first thing is the axis of symmetry. So if you take a look here, on this dashed line, this parabola is symmetrical about that dashed line. Okay, it could be folded in half. So the axis of symmetry would be where is that parabola or quadratic function symmetrical about. The vertex is always going to be the absolute lowest point or the absolute highest point. So in this case, here's our vertex. In this particular problem, the vertex ended up being at 2, -6. All right, so we're going to talk a little bit more about the axis of symmetry and vertex. We can actually find the axis of symmetry by just figuring out this simple equation. X equals -b over 2a. And the axis of symmetry is always going to be what the x-coordinate of the vertex is, -b over 2a. So let's just check that with our previous example. So we just saw that the axis of symmetry would be -b over 2a. Well, looking at this equation, -b would be a +12 over 2 times a is 3. So 12 over 6 is 2. Well, x equals 2 should be the axis of symmetry, and sure enough, that is our axis of symmetry, x equals 2. X equals 2 should also be where our vertex is, the x-coordinate of our vertex, and lo and behold, the x-coordinate of our vertex is 2. The other thing we're going to be focused on is where our parabolas cross the y-intercept, so what the y-intercept is. Here, in this case, the y-intercept is 6, okay? And if you take a look, 6 can also be found as that c value in the equation. So when we are trying to figure out where we cross the y-intercept, that happens when x is 0. So if we take a look at our general form, ax squared plus bx plus c, if our x is 0, if those are both 0 values, we are always just going to be left with c. So that gives us where we should cross the y-axis, or what our y-intercept is. We can also have maximum and minimum values. First off, if a is positive, so if a is greater than 0, the parabola will open up. And that makes us have a minimum value because we have a point that could be the lowest possible point. If a is less than 0, that means we open down. So our parabola would look like this. And here, this then would be called a maximum value because that would be our highest possible point. Regardless if we have a minimum or a maximum, though, those values always happen at the vertex. Okay, so we're going to do another example of graphing, and we're going to do it by finding a few things first. So we are going to find the y-intercept, the equation of the axis of symmetry, the x-coordinate of the vertex, and we're going to make a table of values that includes the vertex and then graph based off that function. So first off, let's go for finding the y-intercept. The y-intercept is when x is 0, so if we have the function f of x is equal to negative 5x squared minus 10x plus 6, if our x is 0, we are just left with 6. So here our y-intercept is 6. So we know y-intercept is 6, that's going to have to be there. 1, 2, 3, 4, 5, 6. We know that's a point. All right? We want to find the axis of symmetry. Well, the axis of symmetry is from the formula negative b over 2a. Well, negative b here would be a positive 10 over 2 times a, so 2 times negative 5. 2 times negative 5 is negative 10, so positive 10 over negative 10 is negative 1. So our axis of symmetry for this is x equals negative 1. Which also means the x-coordinate of our vertex is negative 1. So now we're going to make a table of values. So x, y, we don't really need to find 0 because we know 0 is already going to be 6. And then notice our axis of symmetry here is at negative 1. So we're going to plug negative 1 in for sure. And then we'll also plug in negative 2. Because we know we should be symmetrical. So negative 1 is our vertex. So negative 5 times negative 1 squared minus 10 times negative 1 plus 6. Well, negative 1 squared is a positive 1, so this is just negative 5 plus 10 plus 6. Well, negative 5 plus 10 plus 6 should give us 11. So this is 11. So we have negative 1, 11. 1, 2, 3, 4, 5, 6, 7. Ooh, I ran out of graph. So we have two options. You can just keep counting up, or what I'm going to do here is I'm just going to adjust my scale. So I'm just going to move my x-axis down to here. So this is now my x-axis, and I'm going to plot from here. So 0, 6, 1, 2, 3, 4, 5, 6, and negative 1, 11. So 6, 7, 8, 9, 10, 11. This is also the axis of symmetry. Because that's the axis of symmetry, since we have a point right here, we should have the same point on the opposite side of that axis. So we should have a point right here, which would be at negative 2, 6. So if you were to plug in negative 2 over here, we should get a positive 6 out. So negative 2 squared is positive 4 times negative 5 is negative 20. Negative 10 times negative 2 is positive 20 plus 6. Lo and behold, we actually got that 6. Those 3 points are sufficient enough for us to graph that quadratic, so we will connect those and get the idea of what the parabola looks like. So here's our table of functions. Our table of values, we included the vertex, and we had a couple of other points so we could see what the parabola looks like. And we're going to do one more example dealing with maximum and minimum. So we want to determine if this should have a max or a min, and then we want to find that value, and then state the domain and range. First off, the a here is greater than 0. Since the a is greater than 0, our parabola opens up, which means we would have a minimum. The minimum is going to happen at the vertex. We know the vertex happens at the axis of symmetry, so negative b over 2a. So in this case, our b is negative 24, so a positive 24 over 2 times 4, or 24 divided by 8 is 3. So our vertex should happen when our x value is 3. So we're just going to plug our 3 in for our x value and see what y should be. So 3 squared is 9 times 4 is 36. 24 times 3 is 72. So we have 36 minus 72, and then we want to add 11. So 36 minus 72 is negative 36, plus 11 is a negative 25. So this means that our minimum, our vertex, should be at the point 3, negative 25. Okay? And then we want to state the domain and range. Well, if you think about this parabola, just the general shape of it, we know this point down here is at 3, negative 25. Well, first off, the domain, the x values can be anything. So x can be in the real numbers. But the range here does have restrictions. The range has to be above that value. The range is dealing with y's. So the range, the y values, all have to be greater than or equal to negative 25, because we already established that negative 25 here would be that minimum point for y. All right, so that is how we are going to be graphing our quadratics.